Okay, in this one we're still doing two samples, but here the samples are dependent. And what we're really looking at is the difference between those paired samples, between the entries, the paired entries in these paired samples. So that's why we're talking about the mu d, the mean of the differences. So if we're being asked to claim, we're claiming that the mu d equals 0. All right, so that has to be the null, and then mu d not equal to 0 is the alternative. All right, and let's see. We have our given information here. But again, in this one, we've been, the work has been done to get us to our p-value. So we can go straight to that step. We have 0.00, oh, I don't know, there's a lot of O's and then a 3. A lot of zeros in there. So this is really small. That's our p. It's definitely less than our 0.05, our alpha, much less. This would be reject H0. Okay, where H0 was our claim, we rejected it. We had the evidence to reject it. So there is enough evidence at 5% significance level to reject the claim. All right, let's do a similar thing here with different information. Mu d less than 0. Okay, that would have to be the alternative, where null is mu d greater than or equal to 0. This is the claim. Again, all this information has led us to this p. Oh no, we have a different alpha level, significance level than usual, 10%. But again, this p-value is tiny again. So this is definitely less than 0.10 or alpha. And so we reject H0. This time the claim was in the alternative. So that means that we're support mode. We did reject and got ourselves to the alternative. So there is enough evidence at 10% significance level to support the claim. Okay. All right, let's now use SPSS to see how we could gather this information from the SPSS output. So a pharmaceutical company wishes to test a new drug, expectation of lowering cholesterol levels. The subjects are randomly selected and pre-tested. Okay. All right, so test the company's claim that the drug lowers cholesterol level. Samples are random, and we're using a 1% significance level. So there's the data there, which has been used to generate this information from SPSS. All right, well, this time let's actually set it up first, and then we'll go and look at what we had. Okay, so what we're going to do is we're going to say that since we're dealing with before and after, all right, so I'm going to take the difference to be the before minus after. All right, so if we're trying to claim that the drug lowers cholesterol level, that would mean it would be higher before and lower after, big minus smaller. That would mean we'd be saying that this D is greater than 0. Hence, mu D greater than 0 would be our claim. So mu D greater than 0, mu D less than or equal to 0. Okay, so our claim here. Okay, so we're set up. Now we need to go in and look. All right, so there was just our sample information, and here's the paired sample t-test. So here's the t that we got, there's the degrees of freedom, and there's the all-important p, except, well, it's our significance, but it is a two-tailed. Our problem here is a one tail. It happens to be a right tail, but it's a one tail. So I'm going to have to take half of that. So when I go talk about what the p-value is, it's going to be 0.022 divided by 2 equals 0.011. Okay, now I have to compare that 0.011 p-value to my 0.01 value for alpha. It's slightly bigger than, so I will have to fail to reject H0 here. So what does that mean? Again, claim was in the alternative, so that's support. I was not able to get there. There is not enough evidence at 1% significance level to support the claim, which was that the drug lowers cholesterol levels. Okay, so not enough evidence to support in this case. Okay.